In this lesson, we are talking about vertical and corresponding angles. Some notes to remember are that vertical angles are congruent. So vertical angles are always across from one another at an intersection. So if we have these two lines, the ones opposite of each other are congruent, and the same goes for the ones on the other sides. They would be congruent as well. Now with parallel lines, they're marked a couple of different ways. They can be marked with the arrows like this. Sometimes you'll see double arrows like that. Or they can be written out in the sentence that's given to you. So if we have line J and line K here, you could just be told that J is parallel to K without the arrows necessarily being there. All right, just as a reminder, a line that passes through two or more parallel lines is called a transversal. So if you have two parallel lines, again, they are noted with the arrows, and then a line that passes through them, that is called the transversal. When you have parallel lines that are cut by a transversal, they form two of the same intersection, just in different locations. So where these two parallel lines are cut by this transversal, that forms two of the exact same intersection, just in different locations. So these four angles, so that's this angle, this one, and this one, those four angles are the same as these four angles. Okay, so all of those pairs are the same. They're just in different locations. All right, now some about corresponding angles. Corresponding angles are when you have your parallel lines that are cut by a transversal. The angles that are in the same location, just at each intersection, are called corresponding, and they're congruent to one another. So this angle and that angle fall in the same location. You could pick any angle at any location and find its corresponding angle at the other one. So if we picked this angle, then this would be its corresponding one. So they were both in this location. All right, and as a summary for vertical and corresponding, if you know one angle measure formed by two parallel lines in a transversal, so if these two lines are parallel and they're cut by this transversal, you can calculate all the other angle measures only using corresponding and vertical angles. So let's say, I'll make this easy. If this is 100 degrees, and that's all I told you, you could find all 7 of the other angles just by using vertical and corresponding angle measurements. So if this is 100, then this one is congruent to it by vertical angles, so that's 100 as well. Well, if this one's 100, then this one is also 100 because they're corresponding angles. If that bottom left angle is 100, it has a vertical angle right here. Now, just using that information, now you can use either your linear pair to find the other angle measures. So if this is 100, this one would be 80 because it forms 180 degrees. And again, we have 80, 80, and 80, all by vertical angles and corresponding angles, along with the linear pair. Let's do some examples. So what is the relationship between A and B? Well, A and B, again, if you think about their location, they're in the same location, just in their different intersections. So A and B would be corresponding. What is the value of x in the figure below? So the top angle and the 103, they are in the same location of those intersections, so they are corresponding. So if they're corresponding, they're congruent. That would mean that 2x plus 3 is equal to 103. So then just solve for x. So subtract 3 on both sides, and you would get 2x equals 100. So x equals 50. Number 3, what is the value of x in this figure? All right, this one's a little bit trickier. Be careful here. Notice that they do not both say 3x plus 2. One says 3x minus 2. So we need to use some corresponding angles here. So if this one is 3x minus 2, then this one is also 3x minus 2. Okay, so you could go that route, or you could say if this angle is 3x plus 2, then this angle is also 3x plus 2. Whichever way you go about it, you're going to have to add them together to get 180, because both of those form a straight line. So 3x plus 2 plus 3x minus 2 equals 180. So we can drop the parentheses at this point because we don't have to distribute anything. I just put them there as a precaution. So 3x plus 2 plus 3x minus 2 equals 180. That gives us 6x, and then positive 2 minus 2 is 0. So just bring down the equals, 180, and then divide by 6 on both sides. So that would be x equals 30. Number 4, what is the value of y? Okay, this one's also a little bit tricky. It's not too bad though. Use the same process that we did before. So we know that 3x plus 7 corresponds to this angle here, which would also be 3x plus 7. Now we have a linear pair, so these two form this straight line, right? So what we know is that we can solve for x by adding 2x plus 1 plus 3x plus 7, because that forms a linear pair to be 180. So essentially our long game here is to find out what is this angle, and then this one is going to have to be whatever it would add to be 180. So that would be 5x plus 8 equals 180. Subtract 8 on both sides. Whoops. So 5x equals 172. And then just in a calculator, let's see if I can pull up Desmos. Whoops. What in the world? I can't seem to get it. What in the world? There we go. Sorry about that. Okay, here we go. If we divide by 5 on both sides, 172 divided by 5 is 34.4. Okay, 34.4. What would y have to be? So 180 minus 34.4 would give us 145.6. So the value of y is 145.6 degrees. Alrighty, now we have, what is the value of x here? Right, in this one, we actually have vertical angles, so they are congruent, and we would need to use just 92 equals 6x plus 2. Right, because they are equal to one another. So subtract 2 on each side. So 90 equals 6x, and 90 divided by 6 is 15. All right, number 6. If the measure of angle 1 is 3x minus 5, and the measure of angle 2 is x plus 55, what is the value of x? Okay, so notice we've got two sets of parallel lines. So these two are parallel cut by these two, which are also parallel. So what we have here is essentially 4 of the exact same intersection, just in 4 different locations. So this is the same as this intersection, same as this one, same as this one. So what that means is that we can use corresponding angles to map angle 1 onto angle 2 to figure out how are they related. So if we have angle 1, that would correspond to this angle, and that actually would also correspond to this angle. Okay, so if you think about that intersection, this one aligns with this one, which aligns with this one. So essentially what we have here is that angle 1 is equal to angle 2. So 3x minus 5 equals x plus 55. And now we want to solve for x. So I would first just move that x over, so subtract x on each side. So now we have 2x minus 5 equals 55, and then add 5 on each side. So 2x equals 60, so that would be 30. All right, and number 7, what information is needed to prove that the lines are parallel? So notice they don't have any markings, but if we knew something about those angles in those 2 different intersections, then we could say that the lines are parallel. So angle 1 and angle 4, let's look at those. Angle 1 and angle 4, we already know that they're congruent. So we don't necessarily need to prove that, because really that only involves this intersection. That has nothing to do with this intersection below. So angle 1 being congruent to angle 4 doesn't help us out. Angle 5 and angle 8, that's kind of the same situation, just with the opposite line. So these 2 angles are congruent because they're vertical, but we don't know anything about this line. Angle 2 and angle 5. Okay, well, for angle 2 to be congruent to angle 5, that would mean what? Well, this would have to be congruent to this, and that doesn't correspond to this one. So that would still leave me with a question mark, because I don't know that that can even be true. And then let's look at angle 2 and angle 7. Angle 2 and angle 7. Okay, well, if we use vertical, that would get us to 3, and corresponding would get us to 7. So using 2 is congruent to 3, 3 would be congruent to 7 by corresponding angles. That could allow us to say these 2 lines are parallel, because we would have a pair of corresponding angles within them.